LCISD Science, Grade 8, Unit 6, 2016-2017. Use the following situation for the next two questions. You are riding in a vehicle with a coffee cup on the dashboard while traveling 30 kilometers an hour. This vehicle makes a sudden stop to avoid hitting the car that has stopped in front of it. Number 1. What would happen to the coffee cup? A. Go forward. B. Go backward. C. Stay stationary. D. Straight up. Number 2. When a car suddenly stops, the object in the back seat are thrown forward. This is due to the F. Law of inertia, G. Law of force and acceleration, H. Law of action, reaction, J. Law of gravitation. Use the following information for the next three questions. An experiment was conducted to see how mass of an object affects the amount of force needed to hold it still on the ramp. A spring scale. Number 3. How much force is needed to hold the 2-kilogram object? Number 4. Which Newton's laws describes the relationship between the mass and force? F. Law of inertia, G. Law of force and acceleration, H. Law of action, reaction, J. Law of thermodynamics. Number 5. If the object is not moving, where is the acceleration coming from to cause the force to increase as the mass increases? A. Friction, B. Spin of Earth, C. Gravity, D. Movement around sun. Number 6. Sir Isaac Newton was born on December 25, 1642, and died on March 20, 1727. Even though most people know him for his laws of motion, he was also a mathematician, astronomer, natural philosopher, alchemist, and theologian. Newton built the first practical reflecting telescope. Until this time, telescopes were based off of Galileo's refracting telescope. He also experimented with light, developing the idea that white light is formed by the combination of the colors of light in the visible spectrum. In mathematics, Newton helped develop the mathematical ideas of differential and integral calculus. Which of the following was Newton not credited with discovering? F. Calculus, G. Refracting telescope, H. Formation of white light, J. Laws of motion. Distance, time. Number 7. The uniform motion of a car is shown in the distance versus time graph. What is the average speed of the car? Number 8. The average speed of a car is 20 meters per second. How much time does it take for a car to travel 300 meters? Number 9. Christina and Juan are standing still on their rollerblades. What happens when Christina pushes Juan from behind? A. They both travel forward. B. They move closer to each other. C. She moves backwards and he moves forwards. D. He moves forward and she remains where she is. Number 10. Based on this graph, which is constant? Distance, time. F. Displacement, G. Position, H. Time, J. Velocity. 11. The distance versus time graph below shows data collected as a remote-controlled car moved across a level parking lot. Distance, time. According to the graph, which of the following conclusions about the car's motion is supported? A. The car is accelerating. B. The car is stopping and starting. C. The car is traveling at a consistent velocity. D, the car is moving through an obstacle course. 12. A student jumps off a sled toward the west after it stops at the bottom of an icy hill. North, east, south, west. Based on the law of action-reaction, in what direction will the sled most likely move as the student jumps off? F, north, G, south, H, east, J, west. Number 13. During a demonstration of Newton's law of motion, a student used the setup shown in Figure 1. The student flicked the index card with a fingertip and the coin fell straight down into the plastic cup, as shown in Figure 2. Which of these best explain why the coin fell straight down into the cup instead of remaining on the index card? A, the coin was at rest until the card was removed, so its tendency to remain in the same location. Once the card is gone, the unbalanced force of gravity caused the coin to fall. B, moving the card applied an action force on the coin. Since the card was gone, gravity applied a reaction force on the coin. C, the card had less mass than the coin, so a smaller force of gravity acted on the card. The larger force of gravity on the coin made it fall. D, the acceleration of the coin falling into the cup was equal and opposite to the acceleration of the card. 14. Two cars with different masses travel at the same speed down a hill toward a stop sign. What will happen when both cars apply brakes at the same time to stop? F, the car with the smaller mass will require less force to stop than the car with the greater mass. G, the car with the larger mass will maintain its velocity while traveling down the hill. H, the car with the smaller mass will take longer to stop than the car with the larger mass. J, the car with the larger mass will have less inertia than the car with the smaller mass. 15. 4 students raced toy cars on a track. The mass and the acceleration of each car is recorded in the table below. Toy cars, toy car, mass, kilograms, acceleration. Which toy car had the greatest applied force? 16. Sometimes tectonic plates do not move easily past one another and the plates become stuck. Forces build up, and when the plates finally move, tension is released as shown below. Seismic waves, plates, epicenter. The sudden movement of the plates is caused by F, the mass of the plates, G, the weight of the plates, H, unbalanced forces, J, gravitational force. 17. A student lets a toy car roll 4 times down a ramp that is 1 meter long. Each time the student covers the surface of the ramp with a different material. The student measures the time it takes the car to roll down the ramp and records the results in the table below. Material, time to complete ramp. Which of the following would be the best conclusion based on the data in the table? A, different surfaces affect how fast a toy car accelerates. B, different toy cars travel at different speeds. C, gravity has little effect on the speed of toy cars on different surfaces. D, air resistance is the greatest factor in limiting the acceleration of different toy cars. 18. The masses of 4 vehicles and the net forces acting on them as they enter a highway are recorded in the table below. Vehicles entering a highway, vehicle, mass, force. Which vehicle has the greatest acceleration as it enters the highway? F, sedan, G, coupe, H, SUV, J, truck. Number 19. The diagram below shows two different forces acting on a cyclist riding a bicycle. F, air, equals 84 newtons. F, applied, equals 150 newtons. The total mass of the cyclist and the bicycle is 100 kilograms. Based on this information, what is the acceleration of the cyclist? 0.66 meters per second square backward, because the force of the air slows the cyclist down. B, 0.66 meters per second squared forward, because the applied force is greater than the force of the air. C, 2.3 meters per second squared backward, because the forces are opposite and not equal. D, 2.3 meters per second squared forward, because the cyclist's inertia is greater than the force of the air. Number 20. Describe the action and reaction forces of an ice skater performing a jump. Make sure and use complete sentences with a capital letter and end punctuation at the end. 3 to 5 sentences